Okay, that was just a blooper. Okay, so here we go. Um, so we just spent a long time not recording and discussing Anthony's code for the who shall remain unnamed for uh, for the pool game. And so you see that, so the pool table is sort of embedded in the middle of the window, not occupying the whole window, and that's a good thing because then you have this space for instructions and a little scoreboard up here. And the instructions say move the white ball with the arrow keys. Is that? Oh yeah, so I can move the white ball around with the arrow keys. Okay, I can't move it to the right to this line. Okay, so that's that D line. Sure, that makes sense. Yeah, that's a nice little black line that says you have to place your cue ball to the left of this line before you can break. So if I then hit space bar, I get my cue stick, which I can rotate around here, and look how nice that is, because then, you know, it's sort of customary to hit the one ball somewhere at some angle, right? And then I can hit the up arrow, and it pulls back the cue bar, and it gives me my paro window, and I hit space again, boom, there go all the balls. And one thing I notice about this is that my window, it's hard to tell the 8 ball from, maybe it's just my eyes. This is the 6 ball, and that's the 8 ball. They're pretty close. I think I accidentally sunk the 8 ball on purpose by accident because I thought it was the 6 ball. In any case, so now it's wide open. Notice that the suit is not now player. Player is a garbage value. I'm not sure why that is. That's something I'm looking for as I read through the code. Where does the player get set and printed onto the scoreboard there? Yeah, yeah, it is very clean. Yeah. So I get to pick whatever suit stripes or solids that I want at this stage, right? So I want to sort of pick my easiest shot, which may well be this one. I find that it's difficult to tell where it's going to hit, right? Because it's going to follow this line. It's not going to hit where the line hits the ball. It's going to hit where, the ball. Yeah, so I think I actually want to go a little bit like that, right? So when the cue ball is here, well, maybe a little bit farther, like that. I don't know. So when the cue ball is here, it's going to bam into that thing. I'll probably miss. Let me try about there. And the other thing I noticed that you should use the very end of the cue stick. Okay. And do I want to hit it hard? Maybe not too hard, huh? Oh, I cut it a little bit. Oh, and I scratched. Okay. So what does that mean? Move white ball with the arrow key. So apparently now I can move the white ball wherever I want. My understanding of pool is that you can't do this, right? You have to you have to put the ball on this side of that line, but maybe not. You scratch, you get it like a freebie, right? Which I'm glad to take. I think do it. And so since I still have the choice of solids or stripes at this stage, I might want to think. If I want to run the board, would it be easier to run in stripes or run in solids. Well, I'm kind of looking at the solids as being pretty good here, partly because, yeah, I can hit that. What is that? The 4 ball, and have it hit the 6 ball into the pocket. Okay, I'm gonna hit the space bar, and yeah, occasionally this happens, huh? You lose the oh, there. Okay. So now I want to hit this ball so that it hits that ball, right? And it's pretty sensitive to this point of impact, right? I didn't hit it hard enough. I forgot to pull it back. Okay. So it's still wide open, and this player then can say, "Yeah, I'm going to hit that with some force and hope to get another ball in the process, right? So bam, okay, I didn't get anything. I didn't touch another ball at all. But now I'm solids, right? You can see up here in the upper left corner, suit solids. Um, okay, and so I want to hit another solid ball in another pocket, and not the 8 ball. I know that looks like a solid ball, but then that's losing the game. Okay, so if I hit this ball, I don't know. I don't want to spend too long on this, but yeah, right. See, but you get a feeling it's like pretty realistic, right? I think maybe there's a little bit too much friction, but okay. So now I'm stripes, and stripes may want to do something like this. Oh yeah, I know. This is about how good I am at pool in the real world. Okay, so that looks like a pretty dead-on shot, doesn't it? If I hit it right there. Yeah. Oh, I was solids, right? Yeah, okay. So now notice the solids is remaining is now 5. And let's see, what shall I hit next? I could hit this, hit a bank shot. So if I hit that bank shot, that's bad, right? So I want to hit it a little bit like that so that it does this and that. And not likely, huh? Okay. All right, so you get the idea. Anyway, so I will continue to read through this. I find it very instructive. Some great ideas in here, and maybe we can have Anthony share some of the process that went into this. But great work, yeah. Uh, and what's next on our agenda? Um, I guess I have to close this. As much as I'd like to just play pool for the rest of the, this is being recorded, and maybe the authorities will say, "Wait, this guy's just playing pool. What are we paying this guy for?" And so on. So, all right. So back to the browser window, where we see our agenda has chapter 7. Oh yeah, so we better get into this. We got like like a half an hour before the break, so let's get started on that. And this is where we learn the nitty-gritty of memory management. And I'm going to try to get through this fairly quickly, but I don't want to skip over important things. So if we go to the textbook, you can see here's 17.2 vector basics, right? So the idea is that if you have a vector of double, so this is the standard template library, right? So if we say I've got a vector of 4 doubles, and then I can just use the assignment operator to initialize each one. And then what I'm going to end up with is a location in memory associated with the name age. Now, if this were an array, then we'd just have this, right? These guys here. And the name of the array would be the address of the first element in that array. Here, however, the name of the array, well, what is it? So I think can we bring this up on the which one is this? This is if I go to my code window and say not that one. Is it this one? Nope. It's not that one. Okay, yeah, it's this one. And let me bring that up over here so I can play with it. Okay. So yeah, so here we're using the built-in standard template library vector, and we declare and initialize the vector, and then we're going to say if I were to define my own class vector, it might look like this, right? I might say, look, I need, what do I need to define the vector? I need a number which says how big the vector is, right? So that's this 4 here. And then I need a pointer to the first element of the array, which holds the contents of the vector, right? However, notice that in this code, we're using the standard template vector in main, and we never use this vector, right? So, but this is the idea of this code down here is not that this is what we're using here. It's just this is sort of a schematic of what you might do. You'd have a member variable of the vector class, which has two main things, right? One is an integer saying how many elements are in the vector, and another which is a pointer to the first of those things, which is essentially an array, right? But the array now knows how big it is because it's got a variable for that, and that's so a vector is a wrapper around an array that includes a variable for the size. And then we'll have a constructor that says I want to construct a variable of size s, and I want a function that returns the size. So that's the kind of thing you might want there. But so let's run this, and let's do we need any members? Yeah, so we probably want include IO stream, and using namespace standard here. He doesn't necessarily expect you to run these things, right? But let's have a little for loop for double D in age. I'm going to see out D followed by a space, and then I'm going to see out end line, and let's just take a look at the output of that. Do we have output? Yeah. So there are the elements of that, the 4 ages, and so what I'm curious about here is what happens if I try to see out age. Or age, what is age? Like if it were a vector, it would be an address. Sorry, if it were an array, it would be an address, right? Oh, yeah, see, it doesn't like that. Can I say address of age? Yeah, see, I can do that. Let's see, what does that print out? It's going to print out some address, right? Yeah, so age is at this location in memory. What if I try to dereference that thing? To see what's age equals, dereference that memory? Is that doable? It doesn't like that. No operator found. So yeah. Now, because it's a standard template library object, it's got a member function called size, which kind of does what this does, right? Returns that member variable. Right. And I'm not sure why I said equals 4. Oh, I see. I just forgot to have a new line there, right? Okay. Okay, I don't want to belabor this. We're just going to take for bloody ever. Right. Okay. So now what? Next. Okay, so I'm gonna, this is 17.2, gonna exclude that from the project. I'm gonna bring in existing item, which is going to be 17.3. Is it 3.1 or just 3.3? Just try 0.3 and see what that is. So I think, yeah. So this is talking about pointers, and yeah, I mean, heretofore we just sort of talked around them and never really addressed the issue directly. So let's go to the text and see what he says here. 17.3. Memory addresses and pointers. Okay, so memory is just a sequence of bytes. A number that indicates a location in memory is an address. A number that indicates a location in memory is an address. You can think of an address as a kind of integer value. It's not an integer value, though, right? Because you can't, I mean, it doesn't have integer type. It has address type. So the first byte of a memory has address 0, and the next one 1, and so forth. And you can think of them as numbered bytes from 1 to the end, or from 0 to the end. So a pointer is a variable that contains the address of another variable, right? So, you know, here somewhere in memory we have a name called pointer, which is a variable type pointer to int, and it contains the address of a variable, right? And say that address is 4096, then this is going to reference this location in memory. 2 to the 12th is 4096. And suppose there's a 17 there, then, well, this code will, what it will do. So let's go ahead and look at that code. So we've got an integer, a variable type int called var, which is initialized to 17. And, you know, to emphasize that this is an initialization, let's do it that way. Yeah. So here we're declaring this. We can do the same thing here, right? Which is to say that's so PTR holds the address of var. Right. So then these are kind of bound up together. Right. So if I say I've got another pointer to character, I would do that in a similar fashion, right? Except that again I'm using the assignment operator, where really more modern C++ would have us using curly braces to initialize a variable. And here I've got an integer 17 and a pointer to an integer called pi, and I'm going to give it the address of 17 in memory. And again, that's an initialization. You might as well have the curly braces, and then it's going to report on what all those things are. Then what's going to happen? Well, then PC, which was this pointer to character here, which was C, is now going to become X. So what does that do? That doesn't change PC, that changed the contents of the memory location. So this is the dereferencing operator. This says, give me the address that this thing points to. Give me the contents of that address that this thing points to, and change so that the thing that's there we expect to be a character, right? Because this is a pointer to character, right? And we're assigning that a different character, and we're assigning the contents of the address that pi points to a different value, and we're assigning, oh, is this okay? Can we dereference a pointer to character and assign that to a dereference pointer to integer? Well, a character does have, so let's, while we're here, say cout the contents of what pointer to integer pi contains is now going to be different, right? And that's okay because a character is kind of an integer, right? So that's an implicit cast from type character to type integer, which is not a narrowing, right? So it seems reasonable. However, you can't do this, right? Which is what? I'm assigning the address of pointer to integer to an integer. Is a pointer to an integer. Well, he said that you can think of them as integers. They're not integer types, right? So while each address is a number, it's not an integer type. So you can't assign a address to an integer. And this is also an error. You can't assign an integer to an address. All right. Can you assign missing the R in var? Really? That was before, huh? Sorry, I wasn't paying attention. Oh yeah, you're right. Right here, huh? Thanks. Somebody's paying attention. All right. So let's see. This is an error because you can't assign a pointer to an integer to a pointer to a character. Now, they're both addresses in memory, right? So we're just assigning one address to another address. Why isn't that allowed? Well, despite what the Cherno has said, a pointer is more than just an address. It's also a type. I know Cherno says that it's just an address, but it's also, right, if you have a pointer to what, you have to say what kind of object does your address address. Now, there are ways of stripping that information off or changing it, was what we'll talk about. But, okay. So then we're going to have these 4 characters. And, okay, so this is 5. Oh, notice that this is in a new scope, right? I don't know why I did that, but let's go ahead and run this. And what I'm looking to see is this dereferenced character here. What should it be? Well, PC was X, lowercase x, X, Y, Z. I think Z is 95. Is that right? Oh, 90. No, sorry, 97 plus 25. Is 117. I'm going to write that down. 97 plus 25 is, 121. Right, I knew that. And so 119. So that should be 119. Let's see if it isn't. Okay, I'm going to go to the output window. And I didn't put out the equal sign. It was 120. I was off by 1. Okay, that figures. And why do I not have an equal sign here? I don't know. Okay. Right, so X, it has an ASCII value of 120. Y is 121 and Z is 122 because I guess it's, because 7 plus 5 is 12, not 11, as I have written on my page here. That's embarrassing. You get in the habit of just like correcting for being off by 1, and so you overcorrect, and then you're off by 1 again. Great. Okay, so moving on. So there's a little warning here. Yeah, I think we talked about that warning, right? Okay, so exactly how a compiler allocates variables in memory is implementation defined, but we might get something like this after doing all that, which is, you've got an A, B, C, D here somewhere in memory. So this is, stack memory, I guess, which the compiler, assigns, but they tend to put them one after another, barring some other obstacle, right? So it could very well be that if you declare, oops, you can't see that. If you declare 4 characters in a row, then they'll give you, this block of memory. Okay, so now PI is a pointer to an integer, which is the address of character 3, which is C. Okay, that's a C here, right? That's why character 3 is here. And the address of PI is out here. Okay, so what's the point here? Okay, so if you were to assign, yeah, this is kind of an important thing here. If you were to assign the address of character 3 to a pointer to an integer character, right? Which, yeah, this address of character 3, that's, that's okay. Is this in our code here? That was okay. It was. So let's go back to the code, and you can see here that this is actually commented out. Shall we see where these things are? So I'm going to say cout address of character 1 equals address. This is why this takes so long, because I do stuff like this. But I'm going to do it anyway. Okay, and then I want to change this to a 2 and a 3 and a 4, and I guess a 2 and a 3 and a 4. And so let's just see where those are. Oh, this is another thing I forgot about, which I should have expected here. If you insert the address of a character into the console, it behaves different than the address for any other type. The address for a character assumes, oh, you want to insert a C-style string. And then it keeps inserting characters until it gets the null character. So, yeah, so we see that, yeah, sure enough, there's an A as the first character, and then there's a whole bunch of other characters which are garbage characters followed by a null character. So this, this encountered the null character here. Notice that it's going backwards, right? So the B, the next thing it assigned, had a bunch of memory after it, and then the A, which we saw, and then the null character here. Then the C and the D, so it keeps putting the new character before the old character in memory. Okay, so how do we get the actual address? Yeah, so that's going to be tough. Unless these, so let's go ahead and copy all this. Down here, and we'll see about all that, but I'm going to make these integers instead of characters. Can I do that this way? And shall I call this, I don't know, am I using I1, I2, I3, I4, and I don't know, set those equal to values like, actually we could just use these same things, right? Because those are more or less integers. And then if I say the address of I1, oh, can I do that this way? And yeah, okay, so let's see what that gets us. Yeah, so you notice how differently those behave, right? So if you insert the address of a character into the console, it assumes, oh, you want to print a C string, and happily prints out characters until it gets a null character. Whereas with integers, it actually will give you the memory address. And note that these are 32-bit memory addresses, right? It's 1, 2, 3, 4 bytes, but the first byte is always 0. It's because then that's that part of stack memory where it is. And that they're coming after one another. Oh, before, right? Yeah. So the first thing is here, and the thing is here is how many? Yeah, these are all different bytes, right? So how many bytes apart are 0 and C? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9. A, B, C. So there's 12 bytes apart, right? So it looks like we keep subtracting 12 bytes from the previous, which here, these are base 16 numbers, right? So in any case, yeah, I think that makes that point. So then, so I guess, so the argument here is that if you were to, oh, sorry, back in the code, if you were to do this, that is, create a pointer to an integer and assign it the address of character 3. Now, an integer takes 4 bytes, right? So it says point to character 3, a character-sized piece of memory, but then integer-sized piece of memory is going to take 4 bytes. Let's pretend we can do that. What would happen? Or does the compiler even allow it? Yeah, see, it's complaining. What's it saying? Oh, you can't see the context menu. It says a value of type character cannot be used to initialize an entity of type int. Oh, sorry, pointer to int, right? So a value of type pointer to character cannot be used to initialize a variable of type pointer to int. And for obvious reasons, right? So the reason being sort of illustrated in this picture, which is that, if you've got a pointer to an int, which contains the address of character 3, it's going to write over itself, right? Potentially. I mean, not necessarily, but it could well then. That's obviously going to cause problems, right? So you don't want to have that problem, and that's why we do that. So it is unlikely that you really need to convert an int pointer to a pointer to another type of character, but if you needed to, you can use reinterpret cast, and then we'll talk about that later in the chapter. So as Stroustrup says, we're very close to the hardware here. This is not a particularly comfortable place for a programmer. There's the reason why business programmers don't use C++. They use COBOL typically, or at least once upon a time that was true. I haven't kept up with their practices. I think it's probably still true. They use COBOL because you are not close. You can't get close to the memory in COBOL. C++ is both a high-level and a low-level language, so you get direct access to memory, which is dangerous, right? There's the, yeah, let's just leave it at that since we're coming up on the break. There's a few apocryphal stories about that. However, we had to get here to know high-level facilities, right? How high vector facilities such as vector are implemented, right? So you have to get close to the memory. We need to understand how to write code at this level, not because all code can be at a high level. Oh, yeah, not all code can be at a high level. At some point, you have to deal with the memory. Also, we might better appreciate the convenience and relative safety of higher levels of software once we experience their absence. So a lot of this chapter and the next few chapters are going to be like how not ever to do stuff. Like that pool program has a lot of pointers in it. Generally, that's to be avoided. There's even memory allocation using new. That's kind of old school C coding. I mean, that's good stuff. I love C. Yeah. Actually, C has malloc. Does C have new? I think maybe it does now, right? I don't know. I haven't kept up with all that. I remember malloc. That's new is essentially a wrapper around malloc, which is short for memory allocation. I'm trying to think what that is behind me. Oh, that's a lamp. Okay. I turn that on. Is that good? Okay, then was write to an integer-sized piece of memory. Okay, so yeah, so dereference. So yeah, you can write directly to an integer-sized piece of memory. Sure. Oh, I'm looking at the code now. I'm looking at these 2 lines here. Okay, so back to the text. let's see, can we get to so the size of operator, we'll have a try this. So let's take a short break and then we'll do that. Any questions before we do short break? Somebody's biting their tongue about when the midterm is, right? Oh, when's the midterm? No, I don't know. Yeah, I have been procrastinating on that. I think we'll probably have the midterm and final in the last few weeks. This is like week 12, I believe, which leaves 3 more weeks after this week for class time, and then a week for final. So basically, I want to have a midterm that will prepare you for how the final will be, and I just haven't done that yet. All right. So seeing no questions, we'll take 10. We'll pause the recording, and all right. Let's see. Looks like everybody's here. Yeah. And great. Okay. And so the size of operator, well, you talked about this little with this size underscore T type, right? That's what the size of operator returns. So it says, try this. Execute the above example and see what you get. Okay. So I'm just going to copy this onto the clipboard because I'm lazy. And go over here and exclude that from the project. Sure, go ahead, save. I want file, add, new item. So it's going to be, oh, not a class, but a PPP 17 try this 01. I think there's probably another one. So, and who am I? What am I doing? Oh, let's get the code. Okay. And yeah, we're going to need some window dressing here. So this is me doing the PPP 17 try this. The first one. I think there's another one in here too. So I guess what we'll do is say include usual suspects, huh? Stream and using namespace standard, and then down here we'll have function main that will call sizes of well, should we give it a character, an int, any int will do, and a pointer to an int. Oh, okay, so we're going to need a pointer to an int. So I think for that we need an int, right? And so int pointer pi equals x, or the address of x, right? And then we'll pass it pi. Oh dear. Okay. And oh, sizes. Okay. Let's see what happens with that. Here's my output window. And the size of character is 1, 1. So be nice if we had the code side by side with the but yeah, basically if you remind you of the code here, the size of car is size of car And then this is the type, and this is the variable of that type, and it doesn't make any difference, right? If you give it the actual type name, oops, or the, yeah, right. And so why, so it's obvious that the size of a character is 1 byte and the size of an int is 4 bytes, but why is a pointer to an int 4 bytes? Or maybe it's different on your machine. All right, address is 32 bytes, 32 bits, which is 4 bytes, or is it 64 bits, which is 8 bytes? Yeah. Well, I think this will use a 32-bit subsystem of my 64-bit system. So that's what's going on here. All right, so we leave it at that. So we did the try this. And do you want to try any other variables? Could we have a vector? Is that a thing? Can you have, yeah, shall we have more esoteric types here? How about a string? Include string, include, this is why it takes so long for me to get through this. I start fiddling about. So let's just go in here and say, take a couple of these guys, and say the size of, okay, I need to declare a vector, huh? So a vector of int vi, and let's say I've got 4 of them. And so can I just go like with the type here, vector of int, and with the actual object of that type there? Oh, sorry. Thanks. And then string. Oh, this is vector, right? Vector of int. So I'm just experimenting. What I did was just add this these 2 libraries up here, and then I'm just adding this code. So I declared a vector of ints to all 4 zeros, and string s, and can I give it like a hippopotamus? Am I misspelling? I never know how to spell hippopotamus. Doesn't have spell check, so we're good. So the size of string, that's a good question, huh? Is can I actually pass just the type string in here? I mean, that's not a primitive type. It seems to, IntelliSense seems to think it's okay. And I'm going to just give it the actual variable there, and I'm going to run that. Now let's go back to the output window, provided I'm getting some output. I think maybe I didn't close it properly before, huh? Okay, so let's go to the code again. I'm going to say F5. Okay, and then the output window has, yeah, that's kind of interesting. So vector of int is, the size of that is 16. Notice they're consistent, right? So it's if it's just give it the type, or if you give a variable of that type. So it didn't matter that there were 4 ints in my vector of int, or that my string was hippopotamus. How many letters is there's not 28 characters in hippopotamus, is there? So why 28? Why 16? Or maybe, and you may get different values if on your compiler, right, for these things. It's sort of operating system compiler dependent. So why would you need 16 bytes for a vector of ints? Well, you need 4 bytes to say the size, another 4 bytes for a pointer to one of these things. So that's 8 bytes. And then where are the other 8 bytes going? And for a string, it's even weirder, right? 28. There's something about hippopotamus. So should we try a different hippopotamuses plus, and then let's make this 44, and we'll see the output is exactly the same. Right. Yeah, well, it's a little more esoteric with the more complicated container types, right? Let's move on. Stroustrup. So he does say how much memory is used by a vector. Well, we can try that. The output will be something like this. And so in his system, you get 20 as the size, right? So the explanation will become obvious over this chapter and the next. But clearly, size of is not counting the elements. Okay, so free store and pointers. Section 17.4. So the vector that we started writing in section 17.2, we never really got very far from that. But where we never actually implemented it, right? Where does the vector get space for the elements? Unless we're talking about the STL vector, right? How do we get the pointer lm to point to them? When you start a C++ program, the compiler sets aside memory for your code, sometimes called code storage or text storage, and the global variables you define, called static storage. Okay, so that's down here, right? So the code is the actual code of the text of your program, right? And that's got a separate area in memory. I mean, you wouldn't want to write over the text of your program while you're executing it, so it's got its own reserved area. Static data, where this is where I called it stack data, I think earlier. You know, static data. This is where the compiler sets aside memory for your code. Sometimes called code storage or text storage. And for global variables, oh, sorry, that was the code, right? The global variables are static storage. And for functions is also using static storage. That's where your call stack is. And local variables, automatic storage. Okay, so the stack, I was right about that, right? So stack storage is where if you declare, x to be a variable of type int and give it a value, that's going to be stored down here in stack storage. So what's static storage? Oh, those are global variables, right? That's why global variables are handled a little bit differently than local variables. Static meaning that they're always around, right? They stick around. Static cling. So what's the free store? That's the heap is made available. That memory is made available through a call to special operator called new. So when you say something like this, you should read this from right to left, right? So on the right, we see we've got an array of 4 doubles, right? New is allocating memory for that array and assigning the address of the first element of that block of memory, the variable p, which is a pointer to a double. That is, it contains the address of a variable of type double, right? And so what's a little bit off-putting about this is you see the double twice, right? Well, this double is to say I've got an array of doubles, and this double is to say I've got a pointer to a double, right, which is the address of the first of that block of 4 doubles. So this asks the C++ runtime system to allocate 4 doubles in the free store and to return a pointer to the first double. And you can visualize this like that, right? So the new operator returns a pointer to the object it creates. If it created several objects in an array, it returns a pointer to the first of those. If the object is of type X, the pointer returned by new is a variable of type pointer to X, right? So you don't have to have a primitive type. You can have, a pointer to a vector, or your own primitive type. Pointer to ball, as we saw earlier. Okay, and so here we have a problem. This is an error because you were saying, okay, I have an array of 4 doubles. I'm going to assign the first of those. I'm going to allocate memory for those and assign the address of the first of that memory to a pointer to a character, but they're not characters, they're doubles, right? So that's going to be a problem. That's going to be an error. So free store allocation. We must request memory to be allocated on the free store by the new operator, which returns a pointer to the allocated memory. Yeah. The pointer value is an address of the first byte. The pointer points to the object of the specified type. So that means if you're pointing to an integer while the address is a single byte, it's understood that that's the first of a sequence of 4. Pointer does not know how many elements it points to, unless it's a smart pointer, which there are such things, which we'll get to talk about. Okay. So the new operator can allocate individual elements or sequences, arrays of elements, right, as we've seen. Note that the number of elements called can be a variable. That's important because that allows us to select how many objects we allocate at runtime, right? So with regular vectors, you cannot have a variable there, although I'm sometimes surprised by what these new compilers do, so don't hold me to that. Generally speaking, arrays have fixed size, and that must be a constant, right? It can't be a variable. Okay, so a pointer to an int. So PI is pointing to a single int, so that's a single block. Well, a single byte, which is the first among 4 bytes, right? If you have 4 ints, that's going to be 16 bytes, which is 4 blocks of 4. If you have an array of 4 ints. And so for double, they're just, each double is twice as big, so they're sort of indicating that here. Yeah, all right. So you can't assign a pointer to a double to a pointer to an int or vice versa, right? There's no narrowing. Like you can assign an int to a character, but that's a narrowing error. You can't have narrowing errors like that with pointers. There's no implicit cast with pointers. Well, why not, they say, and I think we've already talked about that. And so there's a practical explanation. Theoretically, allowing assignments of pointers of this type would allow for type errors, and we don't want that. We're a strongly typed language. We are C++. Access through pointers, so they use the dereferencing operator, and you can assign using the dereferencing operator. So you can dereference on the right and assign the value of the thing pointed to by P to X. But if you have, so this is dereferencing. If you have the dereferencing over here, that's saying I'm going to assign 7.7 to the pointer P, which is a pointer to the first of 4 doubles. And this is going to assign this double value to whatever address this represents. And then you have the subscript operator, the index operator. And that says that you have an offset from the beginning. So the first one has offset 0 and so on. So P of 2 with the index operator is actually allocating to the third, as we well know. Okay, so that's all. Okay, so ranges. Couple of warnings at the beginning here. The major problem with pointers is that pointers don't know how many elements they point to. Does PD here have a third element, PD of 2? Does it have a fifth element, PD of 4? Neither of those is true, right? Because, oh yeah, it does have a third element, PD of 2, but it does not have a fifth element. And if you start referencing those, C++ won't stop you from doing that using the index operator or the subscript operator, whatever you want to call it. And so you get a range error oftentimes this way. And I'm going to skip over. I would encourage you to read this more closely, but I want to kind of get into this part here. We have to ensure that such out of range access doesn't happen. One of the reasons we use vector rather than directly using memory allocated by new is that vector knows the size that it or we can easily prevent out of range access. One thing that can make it hard to prevent out of range access is that we can assign one pointer to another pointer to the same type, right? So a pointer to a double can be assigned to another pointer to a double, independently of how many objects each points to. So a pointer really doesn't know how many objects it points to. For example, here we got a pointer to a double. Here we got another pointer to a double, which is the first of 1,000 doubles that have been allocated, right? And we can assign a Q of 700, sure. Then we can assign P to Q. Uh-oh. P only points to 1, so we've sort of moved. So P is pointing to here. Q was pointing to here, which is, this is 1,000. Oh, you're not, okay. So this is 1,000 bytes here. You can't see the code, right? Sorry, that was earlier. This is a block of 1,000 bytes. But then Q is reassigned to what P is pointing to. And so what was over here is now lost. So shall we see? Let's get some code on the workbench here. I'm going to get rid of this and bring in something, existing item. What do we got here? 17.4.1. Is that a good place to go here? I think so. Yeah, there's a lot of code here, so let's take these one at a time. I think we've already talked about this. Yeah. So if we were to ask for size of here, oh, we don't have any libraries, right? So this is not actually intended to run, which is why it doesn't include standard library facilities. Will that do the trick? And then say down here, cout size of QD equals size of QD, new line, and I also want to say QI, huh? Oh, PD and QD. Okay. So let's see what that gives us here. What do you expect? Well, I think I'm expecting 8 for each one of those. Oh, 4? Oh, they're integers. Now, I think D. I was thinking D is a double. Right. So all it knows is that it's pointing to, oh, it is a double. So why is it 4? Double is 8 bytes, right? Oh, sorry, it's an address, right? So PD is an address, and that's a 4-byte object, right? So if I were to dereference these guys, then I would get 8, right? Let's put in a little dereference here, and a little dereference there. Here, dereference, there, dereference, everywhere, dereference, reference. And, yeah, those are 8, right? Okay, because those are doubles, right? But the addresses, yeah, may be different on your machine. I guess in the way I've got this set up, it's taking a 32-bit subset of my operating system. Okay, so let's exclude that from the code and bring in the next, which is 4.1, 4.2. Okay, there's only one 4.2. And this is read the first object pointed to by P. So yeah, reading this from right to left, you see I've got an array of 4 doubles, which I'm allocating on the heap. That's what new means. They use that special area of memory. And assign the address of the first of those to P, then dereference P, which should give you a 0, right? Even though it hasn't been initialized, it should be a 0. Is that true? I'm not sure. Yeah, it's just, yeah, it's uninitialized, so it could be garbage, right? Yeah, all we've done is allocated the memory. We haven't assigned anything there. All right, and then the third of those we're going to assign to Y. Then we're going to dereference P, or no, sorry, assign 7.7 to the thing pointed to by P, and 9.9 to the thing pointed by the memory location 2 beyond P. Then we have a local scope here where we create another variable of type double called X, and we assign it 8.8. And then we have another scope. Why are we doing all this? Well, down here we're seeing that P of 0 is the same as dereferenced P. Right. Yeah, okay. They're basically just showing you that this and this are the same thing. All right, so dereferencing P, which is a pointer to a double, the first of 4 of an array of doubles, right, is the same thing you get by saying what double object is at the first memory location with offset 0. None of this is getting printed out, so let's just not even bother running it. Exclude this from the project. Add existing item 4.3. I believe we've got 2 different ones that both crash. Oh, 4.3 crashes. And why? Oh, well, this is going to be a range error, right? This is sort of a classic range error. Should we check this to make sure? So include standard library facilities. And yeah, so here we've allocated memory for 3 doubles. This is assigning 2.2 to the third of those 3 doubles. This is assigning 4.4 to the fourth, and this one is assigning negative 3.3 to the 3 before the first. Right, so you can have an offset which is negative. Then we're allocating 2 blocks of memory on the heap, one for a single double and one for 1,000 doubles. And then we're swapping the memory around, right? Let's see, does this give us a range error point blank? Yes. So you're not seeing that. It says unhandled exception. A heap has been corrupted. Oh no, poor heap. It's now playing pool and smoking cigarettes. Yeah, and so we're somewhere in memory with disassembly. Oh, look at that. We got to the disassembly section, and they're showing us where this happened. Really? Wow, that's pretty cool. Yeah, one of these days I'll brush up on my assembly language. Or not. How are we doing? All right. So I'm going to close that out, I guess. And where does the error come in? I think it must be right here, right? We're assigning, we're trying to access the 701st element of this array and assigning that to some double. If we take that out, right, so that's the out of there, can't comment there, then we won't get any error. Oh, we do get an error. Has triggered a breakpoint. Triggered a breakpoint. And again, it's showing me some assembly code. So why is that? Maybe it's right here, right, where I'm... Yeah, I mean, certainly there's no problem before that, is there? Hello? Oh, I think maybe I still have that window open is the problem, huh? Yeah. I think maybe I still had it open before, right? Okay, so... Oh, do we have a breakpoint here somewhere? It's showing me the value of my variables. So down here, it's saying question mark, question mark, question mark. So P has a memory location. PD has a memory location. Q has the same memory location as P, right? Because we... Oh. And this is signaled a breakpoint right here. Okay. Well, let's stop this and let me try one more because I don't see what the problem is here. It's triggered the breakpoint. Really? Where? Why? Maybe up here, huh? Because these are both range errors. All right, I'm going to get rid of those and then bring them back, right? Oh, and I still have this thing open. Okay, let me close that again and run this anew. Okay, so this is, you know, I can show you the output is just, you know, there is no output, right? So what happens if I uncomment that? So that's an access error technically, and yeah, it says it has triggered a breakpoint. Oh, interesting. So this is a fairly sophisticated compiler compared. I think older compilers would not do this, right? So now I'm getting this watch window here. I can see what my addresses are, and it's telling me to pay attention to what you're doing. You're assigning something outside of its range, and it's complaining critical error detected. And it exited with code 0, but it detected a critical error, and there was an exception thrown. Yeah. Okay. Well, I think older compilers would not have caught that. That there's this very simple range error here. C++ is usually pretty forgiving about assigning values. I mean, this is you know, undefined behavior here. You have not allocated memory for that, and you're playing with it. So who knows? Maybe it's been assigned to something else, or maybe this is trying to assign this bit of memory and saying, "What? But you're using that. I'm confused." Okay. So let's go ahead and close that out. I don't see, oh, I think I have to say stop, right? Okay. So the Solution Explorer, I'm going to, that's 4.3. I'm going to, how are we doing? Fine. Bring in 17.4.4, which also crashes, according to its name anyway. And okay, so here we have a class X and a class Y, and we're using user-defined types here. Okay, so it looks like we're not including any libraries, so if we want to do anything with this, actually, we'll probably want to include let's say standard library facilities. And so this is a very simple class of, constructor. And here's another one with a constructor that takes an int, one argument constructor, no default constructor. This is the default constructor, right? Um, and what's the point of this? Well, we've got a pointer to a double. We've got one that allocates memory on the heap for a double. All right. See the difference between this is going to be in stack memory, and this is going to be in the heap, right? What's the difference? Well, we're responsible for what we allocate on the heap. The compiler is responsible for this, right? And so when we allocate this, we'll have to unallocate it at some point, or that's much more complicated procedure. So here's another one, P2, which is initialized to 5.5. This one is not initialized. And then we're allocating an array of 5 doubles. And obviously declaring PO without initializing is asking for trouble. So if you're if you're going to try to dereference P naught, which has never been initialized, it may not actually have a memory location, right? We talked about that extern business, the difference between declaring and defining. So we've declared P naught to be a pointer to a double, but we haven't defined it. So it may not actually have a memory location, and then if we try to assign a value to that without really having it, that's potentially trouble. Notice he doesn't say that he says it's asking for trouble. Will we get trouble here? Probably. I think our compiler is pretty sensitive to this sort of thing. Yeah. Okay, what else does he say here? So we're allocating more memory for an array of 5 doubles associated with P4, and then we're going to initialize that, assign values to that memory. Yeah, how is this different from this? Is it asking for the same kind of trouble? Well, instead of having, again, it's an uninitialized array, but we're array on the heap. But it's not just, oh yeah, so here we don't even have new, right? So we're not even getting a memory location, right? And so if we're assigning to that this uninitialized thing that doesn't even have a memory location in stack memory, then that could be a problem. Whereas this, the new allocates a memory location, right? Even though it doesn't initialize it, this will initialize it then. So now if we declare px1 to be a pointer to a variable of type x allocated on the heap, or px2 pointer to the first of an array of x, then if we were to try to allocate memory for a y doesn't have a default constructor, right? Since x does have a default constructor, it knows how to allocate and initialize it, right? And so we can do that either here or there. If your user-defined type does not have a default constructor, then this is going to cause an error, as will this, right? And here we're allocating memory. Y does not have a default constructor, but we're calling the actual constructor, right? We're saying, yeah, I want to construct an integer 13. All right. So should we play with this a little bit? We included our. So what do we want to know? perhaps we want to know what all these things are, right? So see out P naught. That's going to be a problem right there. Supposedly that's a memory address, but where? For what? So let's try to compile and run that, and we see trouble. Unidentified variable P naught. What does it say? Uninitialized local variable P naught used. Right. Which raises an interesting question. I think if I were to make this a global variable, then we wouldn't have that trouble. Right? Shall we try doing that? Oh, I guess I better close this output window. Yeah, if I make it global, I get an exception, but somewhere else. Right? It's when I try to assign a value to that thing. So let me comment that out, because it definitely doesn't like that. What does it say? Access violation, writing location 0. Actually, it says I'm trying to write to memory location 00000. Yeah, that's clearly going to be a problem. So should we see that that's in fact what it is? Oh, maybe I should put a little end line here. And let's stop this. Okay, and then compile it without that line and see that, yeah, in fact, there it is. Here's the output. Oh. I've been handed my pool book. Pool, the illustrated principles of pool. This is not the mathematics of it. See, I got a lot of these. This is a pretty good one, though. Let's see, can I go here? And you can see, oh, it's kind of translucent. Illustrated Principles of Pool and Billiards by David G. Alciorte at Colorado State. All right. So where were we? Oh yeah, I was going to show you the output there. So we're getting 000. I have another one called the Mathematics of Billiards, which is also interesting. But this is pretty cool. I'd forgotten I had this one. I went on a pool binge a little while ago. Okay, so yeah, so it's saying that's a memory location. That's like the null pointer essentially, right? It's not a proper memory location. You should not store anything at that memory location. It's not really real. I mean, presumably there is something there, but that's like the bootstrap location for your operating system, maybe, or something like that. Okay. So if I comment this out, it runs and it shows us that this address is what it is. How about these addresses up here? How about P1? Those are all going to be allocated on the heap, so they'll be somewhere. So we've already kind of looked at that sort of thing. If I uncomment this, we'll see there's an error, right? Because it's trying to allocate something that it can't initialize. There's no default initializer. And so we get an error here. Why? No appropriate default constructor. Yeah. So how could we fix that? Well, we could go up here and say, yeah, can I just say int equals 17? I wonder. So I don't even have a variable name there, right? Is that allowed? Can you assign 17 to a type in a parameter list? Yeah, apparently. So let me really verify that by saying cout y equals y, and that should be a memory location. Whoa. Well, it's an array. So yeah, it's the name of the array is the address of the first element to that array, right? Oh, it doesn't like it. Yeah, so okay, so no, that's a type. That's not the name of the array, right? So py1 is the name of the array. And I think that will be the memory location of the first element of that. And then I could also dereference that, and we should see that it's 17. Is that? Yeah. Feel free to chime in with questions if you find this to be mysterious. Oh, it doesn't want me to dereference that? What is it saying here? No insertion Oh, wow, right. We haven't defined how to print one of these things to the screen. Right, so we haven't told the computer how do you do that here. Can we do it with a friend function, which returns a ostream reference operator? It's going to take an ostream reference OS and a pointer to a constant, a reference to a constant thing, y, and then cout os os or return, sorry, so we're returning one of these things which is going to print out well, it doesn't even have a member variable. It just has a constructor, right? I don't know if I can. Um, yeah, I'm a little confused here. Is that IntelliSense isn't complaining? I don't know. Let's try it. No, it's. What is it saying here? Exception thrown. Stack Overflow. Wow. All right. Well, let's move on. Unhandled exception. Yeah. Yeah. Well, we'll talk about stuff like that's pretty weird. But that was one of the crashers, right? So let's end that. How are we doing? It's 4:29. Oh, that means we should probably change tack here. Solution Explorer. Okay, I'm going to exclude this from the project and add an existing item just to see what's next, and then we'll move on because I think probably we. Oh my goodness! Look at all these. We're not even halfway through this chapter, and there's a bunch of 4.3, 4.4, 4.5. So this is talking about the null pointer, and we kind of saw that. So this is a legal value for a pointer, but it's not something you can dereference. You cannot dereference the null pointer. Maybe that's a good thing. That will lead to undefined behavior. Okay, so maybe we need to circle around to the browser and see what the heck. What was our plan? Oh, the end body. Do I have that handy? I've got pool. I've got. No. I'm not even sure where that is anymore. Let's see. Can I find it in a short order? Yeah, okay, I think it's here. So if I go to my code window and say, yeah, this is Visual Studio. I'm going to change its, oh, not its filters, close, but its properties, and I want to have DISA 1. And okay. All right. So this is kind of where we left off with this. So, I'm thinking with the code that, and did I post this? I think I did. In any case, what are you going to do if you want to add a third body? I think it should be very easy. The question is, where do we put things, right? And that's going to involve where is the Earth compared to the Moon and the Sun, in particular the Sun. So we want to get the Sun in on the picture, right? So if we look at, I posted the solution to this, didn't I? Can I bring that up? So if we go to browser and say, is there a date set for the midterm or final exam? Yeah, good question. Well, the final exam, yes. And for that, we can go to our website, College of the Desert. Is that this one? No. That's just back to where we were. So once you got this instructor thing going, it's always hard to find College of the Desert without the instructor. .edu. How about that? That's thinking about it. Okay, it doesn't want to go there. I don't know what the problem is. It's a busy site. Go there. There we go. And I think if you go to catalogs and schedules, this is fall. No, this is spring 2020. If you go to calendar final exam schedule. So our class meets Monday, Wednesday. Oh. I guess the closest would be this one. Oh. No, we meet at 9, huh? So we don't, our footprint isn't exactly here, but the closest one would be this guy here, which puts us into Thursday, May 21st. Let's kind of try to stick to that date. So if, some of you may have trouble beating off your siblings or whatever, whoever, puts the longest nail through the end of their baseball bat. No, you need to come to an amicable agreement. But I think if you tell them, look, this is my reserved time, at 10 a.m. on Thursday? So that's not one of our usual days, right? So, no, you're right. We don't meet at 9:30. So, sorry. Yeah, duh. Sometimes I just need like a voice of reason. Yeah, okay, so we are here, right? And so that would be Wednesday, May 20th. Thank you very much for that correction, right? So right here, May 20th, because we meet at 2 or 2:45, whatever, Monday and Wednesday. So Wednesday, May 20th. So yeah, mark that down. That is a usual class meeting day, so that makes sense, right? That we would meet at that time during the 16th week of our regular semester. Yeah, okay. And very good. So, we were talking about the Earth-Sun distance. So you're gonna have to do some sleuthing, but I think we go back here and say, look, where were the solutions? End body. Oh yeah. So they part of this assignment was. Oh, this was the starter code. Oh, here's the assignment, right? So if you go to the assignment, you'll see. Yeah, you have to do this computation with the center of mass, and you're just going to have one more mass and position. Uh, but again, you're going to be assuming that the center of your coordinate system is at 0, right? And so that when you wherever you place these things, and you just need to sort of solve the system, knowing how far the Earth is from the sun and how far the moon is from the Earth, and just put them in. I guess it doesn't matter. You should start with them all on the x-axis to simplify things. Um, and say the sun is at x1, which is probably going to be negative, and the 0 is then somewhere close to the sun, and that x2 is going to be the Earth maybe, and x3 will be the moon, which is either on the left or the right side of the Earth. I don't think it matters. Well, I mean, there are some issues, right? Is the Earth moving up while the moon is moving down? I think that would be the case if you put it on the left. If you put the moon to the right of the Earth, then as the Earth goes up and the sun goes down, the moon will also be going up, right? Because everybody, if you're on the negative side of the x-axis, then you're moving down, right? That's the sun. If you're on the positive side, then you're moving up. Anyway, we're out of time. It's now 4:38. Are there any other questions? I think you got it to compile properly now. Oh, yeah, okay, sure. I get that message. Um, sure, okay, will do. Uh, and I appreciate that. Okay, so I'm going to pause the recording or stop the recording. Yeah, thanks for that. And then stop